What if you're trying to find the amount of time the isotope has been decaying rather than how much might be left? For example, an isotope has a half-life of 12 hours. How long in hours will it take a 6,400 gram sample to decay to 200 grams? So you can see here, we can just divide in half from 6,400 to 32, to 1,600, to 800, to 400, to 200. And we can see that that's 1, 2, 3, 4, 5 half-lives. If each half-life is 12 hours, that is a total of 60 hours. So the answer to the question here is that it would take 60 hours for a 6,400 gram sample to decay to 200 grams. Okay, what's another way of solving this problem algebraically? So if we remember our equation where n is the number of half-lives, x is the original sample size, and y is the sample size after n half-lives, or in other words, y is equal to x divided by 2. That's how we get a half-life, and then that 2 is raised to the n power, where n is however many half-lives have passed. We can put our final sample size in, which is 200 grams, equals 6,400 grams, our initial sample size, over 2 to the n. We need to solve for n to find out how many half-lives there are. So I do a little rearranging to isolate for 2 to the n, and 6,400 over 200 is 32. So I have 2 to the n equals 32. When I have an exponent that I'm looking to solve for, the only way to do an exponent is some sort of log. And so I use the base 10 log. I take the log of both sides. And what that does is allow the n to come down from the exponent. So n log of 2 is equal to the log of 32, just by taking the log of both sides. And now I can isolate n, where n is the log of 32 divided by the log of 2. And log of 32 divided by the log of 2 is 5. So 5 is the number of half-lives that have passed. Remember that the half-life of the sample is 12 hours. So 12 hours times 5 half-lives gives me the total number of hours, or 60 hours. Okay, so that's how long it'll take a 6,400 gram sample to decay to 200 grams. All right, so what if you're trying to find the half-life of an isotope? For example, a 120 gram sample of an isotope undergoes radioactive decay. After 4 hours, 70 grams remains. What is the half-life of the isotope? So starting with our half-life equation, we put our final amount, 70, in for y, equal to our initial amount, 120, in for x, over 2 to the n. And we do some algebra. We isolate for 2 to the n and solve. That's equal to 1.71. Okay, then again, when you have an exponent there you need to solve for, you have to take the log of both sides and use the rule of logarithms to isolate n. So we get n is the log of 1.71 divided by the log of 2. And when you do that, you get 0.78. So remember that n is the number of half-lives. So we haven't even gone a single half-life in these 4 hours. So that means the half-life has to be more than 4 hours, right? So it takes 4 hours for the sample to decay 70 grams. So to find the half-life, you take 4 hours, divide by n, the amount of time that's passed. So 4 divided by 0.78 will give you the half-life of 5.14 hours.